in this video lecture, a problem on dumpy level will be discussed. Basically, how to solve this problem. So what is the problem? First we need to know that we need to fill up a given field book. Some stations are given, BS, IS, FS readings are given, and reduced level of the first station is given. We need to calculate the reduced level for the rest of the stations. So what we can do, first we will calculate the reduced level by rise and fall method. As all the readings have been given, we can easily find out the rise and fall values by subtracting the successive value from the preceding value. And this method of calculating rise and fall has already been elaborated in my previous videos. You just need to check on those. So after calculating the rise and fall for the stations, the reduced levels can be easily calculated. If it is a fall value, we will subtract it from the reduced level, and if it is a rise value, we will add with the reduced level. So in this way we will calculate the reduced level. The values which has been calculated has been marked in red, and those values which were given have been marked as black. And rise and fall values has been calculated, and the values have been marked as blue. So for arithmetic check, as the rule says, we will add the BS, add the FS, add the rise, and add the fall. So this is the arithmetic check. We will subtract total FS from total BS, we will subtract total fall from total rise, and we will subtract first RL from last RL, and all the subtracted value will be equal to minus 2.003. So arithmetic check is done. Next we move on to calculation of reduced level by collimation method. This is a more sophisticated method and a more easy method because of calculation of less values compared to the rise and fall method. But one thing we must remember, that height of collimation is obtained only at the change point or at the first station, that is the benchmark. So the height of collimation at the first station can easily be calculated because the reduced level of that station is given and the BS is given. So by adding BS with the reduced level, we get the height of collimation at the first station. Then the next stations will be calculated by subtracting the IS values or the FS values from the height of collimation. So the next station, that is the second station, the height of collimation, if we subtract 2.143 from height of collimation, that is 29.883, we will get the reduced level, that is 27.74. And the next change point is where the BS is 1.583 and FS is 0.631. We have the BS value, so we just need to subtract 0.631 from 29.883 and we will get 29.252. Now we will add 29.252 with 1.583 and we will get the height of collimation at the first change point, that is 30.835. So in this way the height of collimation at the first change point is calculated. Next, after obtaining the height of collimation at the first change point, we can calculate the reduced level for the rest of the 4 stations by subtracting the IS from the height of collimation. Then in order to perform the arithmetic check, we will sum up BS, sum up FS. Again, these are the formulas which we need to remember for calculating the reduced level by height of collimation method. And for the arithmetic check, we will subtract total FS from total BS and subtract first RL from last RL. And so the value will be minus 2.003. So arithmetic check is done, and if this type of problem is given, In the exam, we will follow these steps to find out the values which were not given, generally the reduced level values. For these there are two methods, rise and fall method, another one is the height of collimation method. You can choose any one.